Hello students, I am Dr. Sunita Barve from National Chemical Laboratory Pune. Today I am going to talk to you on a module ISAR systems, functions and design, which is part of topic information storage and retrieval. The aspects will be covered are user interface system, query processing system, database modeling system, which includes linear sequential model, hierarchical model, network model, relational model, and the last option is sampling of information retrieval system, which includes OPAC, Dialog, Google, EBSCO and PubMed. Information search and retrieval is a system which allow end users to communicate with the system. We all use ISAR systems in a different way and we all use different searching skills and knowledge for using any ISAR system. While using any ISAR system, user interface plays very important role. Let us look at what is user interface. Every computer system that interacts with users has an user interface, and this is the combination of hardware and software that enables the user to use the system. The user interface is the space where interactions between humans and machines occur. User interface forms an important component of any information retrieval system since it connects the user to the organized information resources. ISAR system can be effectively used only if the user interface is easy to use for the end user. While user communicates with the system through the user interface, user expects good number of records retrieved while using any ISAR system. In any ISAR system, user interface performs mainly two major functions. One is they allow users to search or browse an information, and second is then display the results of a search. Further, user interface also allow users to perform tasks like sorting, saving and or printing the search results, modifying the search query and so on. The success of ISAR system hence significantly depends on the design usefulness of the user interface. Well-designed user interfaces allow users to find the relevant information. Some user interfaces are very interactive. Some expect users to type certain commands. Some interfaces use extensive graphic images so that it is easy for the end user to navigate from one option to other. While designing any user interface for ISAR system, Schneiderman proposed following golden rules of user design. While designing any user interface for ISAR system, Schneiderman proposed golden rules of interface design, which are strive for consistency in terminology, layout, instructions, fonts and color. Second, provide shortcuts for skilled users. Third, provide appropriate and informative feedback about the sources and what is being searched for. Fourth, design for closure so that when a user is using the user interface, he knows when they have completed searching the entire collection. Fifth, permit reversal of actions so that users can undo or modify actions which he was doing. Sixth, should allow users to monitor the progress of a search. Seventh, should keep track of some important actions performed by the users and allow them to jump easily to a formerly performed action. Eighth, should allow users to rectify errors easily. Ninth, should provide plenty of space for entering text in search boxes. Should provide alternative interfaces for expert and novice user. Hence, Easy to navigate user interfaces provide users to search information from a vast array of ISAR systems. Google is a very good and easy user interface which all of us use. Next aspect in our module is query processing system. The query processor has two main tasks. One is query optimization and the other is query execution. Query optimization is a function of many relational database management systems. The query optimizer attempts to determine the most efficient way to execute a given query by considering the possible query plans. The database user retrieves data by formulating a query in the data manipulation language provided with the database. The query processor is used to interpret the online user's query and convert it into an efficient series of operations in a form capable of being sent to the data manager for execution. Now let us look at data modeling system in our module. Data modeling is the process of creating a data model for an information system by applying formal data modeling techniques. According to Steve Hoberman, data modeling is the process of learning about the data, and the data model is the end result of the data modeling process. Data modeling defines not just data elements but also their structures and the relationships between them. Data exists as facts, figures and other bits of knowledge. When lot of data items are put together in a useful form, one can get required information. Thus, data model is a schema to represent facts, figures and other bits of knowledge. A data model is thus a plan for building a database. It is a description of the data about entities, events, activities and their associations within an organization. A database model is a type of data model that determines the logical structure of a database and fundamentally determines in which manner data can be stored, organized and manipulated. The most popular example of a database model is the relational database model, which uses a table-based format. Database management system may provide one or more data models. Most database management systems today are built around one particular data model, although it is possible for products to offer support for more than one model as well. Before 1980s, the two most commonly used database models were used, and they are hierarchical and network system models. Now, there are various data models in use such as linear sequential model, hierarchical model, network model, entity relationship model, relational model, object oriented model. Let us look at linear sequential model. It is a very common data structure, also called as flat structure. The flat model or the table model consists of a single two-dimensional array of data elements. It is simply a list of table of elements with no hierarchical structure. An example of this model is list of students registered for a given course, the class list. There may be no information except student number and name in this type of sequential model. Next model is hierarchical model. This data model uses tree structure to represent relationship among records. For example, an institute has a number of programs to offer. Each program has number of courses. Each course has a number of students in it. A hierarchical model thus consists of collection of records which are connected to each other through links. The tree type data structure is used to represent hierarchical data model and shows the relationship among the institute, courses and students. The highest level of the tree is known as the root in hierarchical model. Now let us look at hierarchical structure were widely used in the early mainframe database management systems such as Information Management System by IBM. This structure allows one-to-many relationship between two types of data. The next model is network model. It is designed to solve some of the problems with the hierarchical model. A network model is very similar to the hierarchical model. In network model, relationships are represented in the terms of sets rather than by hierarchy. This allows the network model to support many-to-many relationships and also solve problem of data redundancy. The network model organizes data using two fundamental concepts called as records and sets. Record contains fields and sets define one-to-many relationships between records, one owner and many members. Records contain fields which may be organized hierarchically as in the programming language COBOL. Sets define one-to-many relationships between records, one owner and many members. The next model is relational model. The relational model was introduced during 1970 as a way to make database management systems more independent of any particular application. Three key terms are used extensively in relational database models such as relations, attributes and domain. A relation is a table with columns and rows. The named column of the relation is called attributes and the domain is the set of values the attributes are allowed to take. A relational database contains multiple tables, each similar to the one in the flat database model. One of the strengths of the relational model is that, in principle, any value occurring in two different records implies a relationship among those two records. The most common query language used with the relational model is the structured query language. Now next model is entity relationship model. The entity relationship model was originally developed in 1976. It unifies the network and relational database views. It is a conceptual data model that views the real world as entities and relationships. In this model, an entity relationship diagram is used to visually represent data concepts. Thus, it provides graphic representation of entities, attributes and relationships. Today, this model is commonly used for database design. In this model, an entity relationship diagram is used to visually represent data concepts. Thus, it provides graphic representation of entities, attributes and relationships. Today, this model is commonly used for database design. Last one is object-oriented model. The object-oriented model facilitates handling of objects rather than records. Now let us look at information retrieval from database. A database is a collection of similar data records stored in a common file or collection of files. Databases are various types such as catalog of books or other types of documents, computerized bibliographies, address directories, full text newspapers, newsletters, magazines, journal and the internet search engines. Text retrieval can be considered as part of the large concept of information management. Now let us look at sampling of information retrieval system and we will look at one by one the concept about OPAC, Dialog, Google, EBSCO and PubMed. There are many ISAR systems currently in use and available on internet. The main difference in these systems is generally the language used to query the systems and the functionality permitted by the language and database structure. The query languages are either based on Boolean algebra or the natural language queries as mentioned earlier. While using ISAR systems, users want to retrieve relevant material while suppressing the non-relevant. There is no way to know which or how many websites or documents in a database are relevant to any search. Thus, one can never be sure that there is a good recall. These are some of the systems which support search and retrieval of documents from a large volume of information. First one is OPAC. Online public access catalogs were previously termed as online catalogs, which first came into existence in libraries during 1970s, and it reached in most of the libraries around the world today. Online catalogs brought significant improvement in access to library resources, even though the content and structure of the records was little changed from card catalogs. Online catalogs provided new searching capabilities such as word search, keyword search, basic search, advanced search based on Boolean logging. Online catalogs also brought search limits based on date, language and type of document. As we know, when we use any integrated library automation software, OPAC can combine data from circulation, acquisitions and cataloging modules and can show bibliographic data of a book as well as can show who owns the book. Whether book is available on shelf can also be seen on OPAC or issued out to any other member. OPAC also shows any other status of the document. Currently, OPACs are termed as web OPACs, and web OPACs today offer a wide range of search options. They may incorporate information retrieval techniques such as word stemming, truncation, weighted searching, use of fuzzy match search logging, natural language processing. Today's web OPAC provide automatic spelling correction of common terms. They frequently provide ability for a reader to save searches via email. They also provide self-service features such as self-reservation and renewal, document ordering, writing reviews, comments, etc. Web OPAC also offer extensive search and browse features. Now, current web OPAC also allow users to read ebooks through web OPAC by clicking on the link provided on the search results. With availability of open source software, library software are providing many features to the users through web OPAC. We looked at the general information about library OPAC. Now let us look at some information about commercial databases available on internet. Dialog is Knight Ridder Information Incorporations. Dialog is one of the oldest online retrieval system. It was completed in 1966. According to its literature, it was the world's first online information retrieval system to be used globally with materially significant databases. Dialog provides over 500 databases ranging across most disciplines and bibliographic, abstract and full text format. It has most comprehensive content collection and most powerful search language available. From concept testing to clinical trials to product launches to patent protection, Dialog delivers accurate, relevant results with excellent speed. Dialog is a unique in the vast array of information covering virtually every subject. More than 30,000 separate serial publications are indexed on Dialog and more than 8,000 of these are in full text. In addition, Dialog includes the full text of many reference works and specialty publications from around the world such as market research and brokerage house reports, patents and trademark registrations, chemical directories and drug pipeline monitoring services, etc. Archival data is also available on Dialog for many sources back to 1960s and 1950s, some even back to 18th century. One of the feature of dialog is information, and dialog is organized into separate databases which can be like a mini library. For many years, dialog system offered users searching based on only one query, such as Boolean based searching. Its primary users initially were only library community members and other professional searchers. Over the years, dialog has provided variations in its services for different classes of users with different skill sets. Dialog's basic command language allow to use 6 commands such as begin, expand, select, display, print and log off. Dialog also allow users to enter a natural language query. The natural language query is converted into Boolean expression and then the search is carried out. Dialog has also introduced web version of its service called as Dialog Web, which offers internet access to the regular dialog search system. Dialog provides use of sophisticated search engine and authoritative databases. Dialog Web provides easy access to the full content over 500 databases, power and precision of dialog through a web browser. Special features of dialog include a flexible and easy to use guided search mode that does not require knowledge of the dialog command language, a robust command search mode that uses the powerful dialog command language which experienced searcher can easily use, database selection tools to help pinpoint the right database for any search, integrated database description, pricing information and other search assistant is also available. It also allows easy to use forms to create and modify alerts, search results available in HTML or text formats, a choice of displaying records or sending search results via email, fax or postal delivery. Dialog also offers guided search which is designed for novice to intermediate searcher who want easy access to dialog's authoritative business, legal, scientific, intellectual property and technical information. Guided search is the default search option for all new dialog web customers. Guided search is the default search option for all new dialog web customers. Command search mode is one more option available in dialog. Command search is designed for intermediate to experienced dialog searcher. It provides complete command based access to the extensive collection of dialog databases. You need to be familiar with dialog commands when using command search option. Now let us look at another database called as Google. Google is the most popular web search engine which was developed in 1998 among the search engines available today on internet. Google navigates the web by crawling. The Google index contains over 60 trillion and over 100 million gigabytes of data. All this happen in about 1/8 of a second. The websites that Google ranks on the first page of its search results for any given search term are the ones that Google consider to be the most relevant and useful. They determine which websites are the most useful and relevant by using a complex algorithm which takes into account 200 plus different factors. Today, Google holds 70% of the search engine market share. Google's opening page is very simple, consisting of just a one query box and links to advanced search section. It also allows to set certain searching preferences like language and display size and links to specialized databases such as images, interest groups, news, product location and scholarship. Google also allows to set search preferences based on images, maps, videos, books, as well as it allows to restrict searches based on country, time and place. Google indexes word by word from all web pages available on internet. While searching for information on Google, Google carry out spell checking and provides a suggestion to the end user. Google also does stemming on entered terms. Google supports basic as well as advanced search feature facilities such as basic and, or, and not. Google also allowed to use advanced search features based on phrase, wildcard, stemming algorithm, fuzzy searching, proximity searching, must include, must exclude terms, range search, etc. Google searches non-HTML formats as well, including PDF documents, Microsoft Office documents, image files, etc. And Google allows to support viewing of such pages converted to HTML format so that the relevant software is not required. Google also allowed to carry out searches based on different advanced search operators such as must include, must exclude terms, phrase searching, wildcard searching, range searching, and file type searching. In a similar manner, Google also uses advanced qualifiers such as cite, URL, in text, in title, in anchor, link, cache are some of the advanced Google qualifiers which can be used to search information on Google. While creating indexes of every word available from web pages, Google takes snapshot of every web page that it has indexed. It is called as cache page. Google keeps backup of every page it has indexed as a cache page. If any user clicks on cached link, Google will take you to the web page as it looked when it was indexed. EBSCO Information Services is a division of EBSCO Industries Incorporation. EBSCO offers library resources to customers in academic, medical, law, corporate and government markets. Its products include EBSCOnet, a complete e-resource management system, and EBSCO Host, which supplies a fee-based online research service with 375 full-text databases, a collection of 6 lakhs plus e-books, subject indexes, point-of-care medical references, and an array of historical digital archives. EBSCO has products such as databases, which include EBSCO provides a range of library database services. Many of the databases such as Medline, Econlit, Academic Search, Masterfile and Environment Complete are content licensed directly from publishers or vendors and are compiled by EBSCO. Another service which the EBSCO provides is Discovery. This product is used to create a unified, customized index of an institution's information resources and a means of accessing all the content from a single search box. eBooks is another product of EBSCO which provides ebooks and audiobooks across a wide range of subject matter. Vidya-mitra is a clinical reference tool for physicians and other healthcare professionals for use at the point of care. Vidya-mitra ranked highest among 10 online clinical resources. Hence, EBSCO serves the content needs of all researchers. It has a powerful web-based retrieval system. As soon as a user logs into the system of EBSCO, user can select database and then click on search option. EBSCO host allow to use basic search as well as advanced search option. The initial search screen presents a toolbar which includes functions that are available at all the times during a search session. The basic search screen supplies a find box in which terms may be entered and automatically checked for commonly misspelled words and alternate spellings suggested. Keywords are the assumed default in EBSCO. Now let us look at another database system called as PubMed. PubMed is a free search engine accessing primarily the Medline database of references and abstract on life sciences and biomedical sciences. The United States National Library of Medicine at the National Institute of Health maintains PubMed database. PubMed is basically an international bibliographic database of over 4,600 biomedical journals from 1966 till present. PubMed also links to molecular biology databases such as nucleotide, protein, genome, PubSet. In addition to Medline, PubMed provides access to older references from the print version of Index Medicus back to 1951 and earlier, references to some journals before they were indexed in Index Medicus and Medline, for instance Science, BMJ and Annals of Surgery, a very recent entries to records for an article before it is indexed with medical subject headings called as MESH and added to Medline, and a collection of books available full text and other subsets of NML records. Many PubMed records contain links to full text articles, some of which are freely available to download from the web. PubMed was first released in January 1996 as an experimental database under the Entrance Retrieval System with full access to Medline. The PubMed database as well allow to carry out basic and advanced searches. The first search page of PubMed is very simple and easy to use. To search PubMed, one enters search term in the query box. If user wishes to use advanced search, he or she is also allowed to use either basic or advanced search feature. PubMed may be searched by entering one or more keywords or phrases into the text box. PubMed will search multiple words as a phrase if it recognizes the terms. Otherwise, PubMed will search the words separately and combine those terms with AND as a default operator. PubMed also automatically try to map search term to a mesh heading. Using mesh, which is called as medical subject headings, helps to achieve specificity in results and may be the most precise way to do subject searches. Mesh terminology provides a consistent way to retrieve information that may use different terminology for the same concepts. In this module, we looked at user interface system, query processing system, database modeling system and sampling of database such as OPAC, Dialog, Google, EBSCO, PubMed. Thank you.